Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about machine learning using Python 3, and in this tutorial we will study about NumPy array copy versus view, shape and reshape. So in the previous tutorial we have already studied about NumPy array assignment. There we have seen about how we can perform a copy of an array, and also we can perform view of an array. So in this tutorial we will see furthermore about both the things. Firstly, we will differentiate both. That means copy and a view has certain differences. These are the main difference between a copy and a view is of an array is that the copy is a new array and a view is just a view of an original array. That means copy creates a new array itself, while the view is just a reflection of the original array. If you talk about the copy, it owns its data, and any changes done in the copy will not reflect into the original array. However, if we take view, any changes done in it will reflect into the original array. Okay, view, as it's already mentioned that it does not have its own data, so obviously as we have told that any changes done here will be definitely reflected. In the previous tutorial also we have seen the examples of both copy and the view in the form of a shallow copy and a deep copy. That means view means a shallow copy and copy means the deep copy. Okay, so here also we can take certain examples. The first example of copy is we need to make a copy, change the original array and display both the arrays. Okay, so let's consider a code here and implement it on Jupyter Notebook. So here it is, import NumPy as NP. We are taking an array ARR, and here are the elements. Then we are creating a new array ARR1, that is a copy of ARR. This is how we create a copy. Okay, so ARR1 is equal to ARR dot copy function. Okay, then what we are doing is we are updating the value of original array ARR0 equal to 42. That means we are updating its 0th index element, that is 1 to 42. Okay, and then we are printing it, and we are also printing the copied array. Okay, so let's save this code, run this code. Alright, so it's quite clear that ARR, that is the original array, its value is updated. However, the copy of ARR, that is ARR1, its value is not updated. Alright, now if we take an example of view, so let's consider a code and implement it. Alright, import NumPy as NP, ARR equal to np.array and ARR1 equal to ARR dot view. Okay, so previously we have performed a deep copy, and here with the view we are performing a shallow copy. Okay, so this is how we write the statement. Okay, then we are updating the value of original array ARR0 equal to 42. Okay, and then we are printing its value, and we are also printing the value of the copied array. Okay, so let's save this code and run this code. Alright, so it's quite clear that if we do change in the original array, definitely it will be reflected into the copied array. So this is the difference between copy and the view. Alright, we make changes in view, and here is one more example that make a view, change the view and display both the arrays. Okay, so we just implement one more code. Previously in this code we did a change in the original array. Now we try to do a change in the copied array, and then you will see the difference. Okay, so import NumPy as NP. This is your original array, and this is the array whose we have created with the help of ARR with a view function. Okay, so we are updating the value of the copied array. Okay, that is ARR1 0 equal to 31, and then we are printing the original array and the copied array. Okay, so let's save this code, run this code. So here is the output. That means it's vice versa. That means if we change the value of original array, it too will reflect into the copied array, and if we change the value in the copied array, it will reflect into the original array. So these are the two cases of view. Okay, alright. Now, how we will check if an array owns its own data or not? Okay, so it's already mentioned that copies owns the data while the view does not own the data. But how we will check? So every NumPy has an attribute base that returns none if the array has its own data, else it will return to the original object. Okay, so it's better to implement a code and decide whether it's a copy or whether it's a view. Okay, so we need to print the value of the base attribute to check if an array owns its data or not. So let's implement this code. Alright. Import NumPy as np, arr equal to np.array. Here are the elements. So x, this is the array who is being copied from arr. Okay, so x equal to arr dot copy. Y is also array. It is been also copied from arr, but in a form of a view. Okay, so the above one is a deep copy and the next one is a shallow copy. Okay, and then we are printing the base values of x and y. This is how we print the base values. That means x dot base and y dot base. And it's clear from the definition previously that if it's a true copy, then it will not return anything. And if it's not a true copy, it will return something. And what does it return? Let's save this code, run this code. So here it is. So it's returning the values. Okay. So while x dot base is returning nothing, y dot base is returning the values. All right. So this is the basic difference between the copy and view functions. Now we will study about shape property in arrays. So what does the shape property means? NumPy array shape. It's the number of elements in each dimension. So basically, what a shape means, it will tell the number of dimensions in an array. So the NumPy array has an attribute called as shape that returns a tuple. Okay, with each index having the number of corresponding elements. So how it returns and what exactly it means, let's consider a code. And we have already studied about shape in the previous tutorial also. Here we are just looking some more examples. So here we need to implement a code where we need to print the shape of a 2D array. So let's implement this code. So here it is. Import NumPy as np, arr equal to np.array. So here we are taking two lists. This is list 1 and this is list 2, and then we are after converting it into array, we are printing its shape. So obviously it's looking clear that it's a 2D array. So let's save this code and run this code. So here it is. So it's a 2D array. So shape, what is the shape tells here? 2, 4 is the output, a tuple is the output. So this tuple means, this 2 means that we are having 2 rows, and 4 means each row consists of 4 elements. This point should be clear. We got a tuple value, and that's what I have told, that 2 means it's a number of rows. We got 2 rows, and 4 means each row consists of the 4 values. Alright, so we can create an array with 5 dimensions using ndmin, this parameter, using a vector values 1, 2, 3, 4, and verify the last dimension has a value 4. So we will consider one more example. So let's implement it. Alright. Import NumPy as np and arr equal to np.array. So we are giving a list here, and we are telling that convert this list into an array of 5 dimensions. So this statement means conversion of this list into array of 5 dimensions. Then we are printing this array, and also we are telling its shape. Okay, so let's save this code or run this code. So here it is. This is a 5-dimensional array. How we can see the number of square brackets here. The number of square brackets are 1, 2, 3, 4, 5. So it's obviously mean it's a 5-dimensional array. And if you talk about the shape of it, so how to tell its shape? What does this mean? 1, 1, 1, 1, 4. Okay. So here we are having 4 elements. Okay. That means we will just name it as we are having like this. 1 square bracket from this one. 1 square bracket and 1 closing square bracket. This will be your first row and the 4 columns. Okay, so here it is. This is 1 row and the 4 columns, and remaining outer of the square brackets are just been telling that it's been 1 more dimensions has been added. So we are having further more other dimensions which are added to it. So it's been the output in the form of a shape of an array. Okay, now Again, there's a question, what does the shape tuple represent? So there is an integer at every index that tells the number of elements in the corresponding dimension. Okay, so that's quite clear here also, that in this dimension 1 we are having 4 elements. Okay, so that's what it has been told here. So one dimension we are having 4 elements. Okay, and then remaining 3 we are just been putting the outer dimension values. Okay, fine. So by reshaping, we can add or remove the dimensions, and we can change the number of elements in each of the dimensions. Okay. Now if you want to reshape from 1D to 2D, so let's consider one more example. We need to convert a 1D array with the 12 elements into 2D array. Here the outermost dimension will be 4 arrays, and each with the 3 elements. So let's consider a code, and then we will understand how we will convert it. Alright, so here it is. Import NumPy as np, arr equal to np.array. Here are a list with 12 elements. It's a 1D, and then we have to convert it into 2D. So in order to convert it into 2D, what we are doing here is we are just performing a reshape for 4, 3. 4, 3 means we are having 4 rows, and each row will comprise of 3 elements, and then we are printing its value. Okay, so let's save this code, run this code. So here it is, it's quite clear. And again, it's a 2D array, obviously, since we are seeing the square brackets like this. So it's a outer, we are having one more additional square bracket, so it's a 2D array, and 3 elements are present in each row. So it's a 4, 3 reshape array of the original 1D array. So it's a 2D. Okay. Now the next thing is, if you want to convert 1D to 3D, let's consider one more example. So we need to convert 1D array with the 12 elements into 3D array. So the outermost dimension will be have 2 arrays that contains 3 arrays, each with 2 elements. So what does it mean? So let's consider the code first, then we will understand what actually we need to do. That means we are having 1D with the 12 elements, and we need to convert into 3D now. Alright, so here we implement the code. Import NumPy as np, this is your 1D array, and we need to reshape into 3D array. So in order to reshape it into 3D, what we are doing here is 3, 2. It means that we are having 3 rows with 2 elements, and then we are further having one more extra dimension, that means which will divide it into 2 more rows. Okay, this 2 will represents 2 more rows of this matrix which we have created. Okay, and then we are printing it. So let's save this code, run this code. So here it is. What I am actually telling is 3, 2. What does it mean? 3 rows and 2 columns. So 1 row, 1 row, 1 row, that means 3 rows, and we are having 2 columns. Okay, it's done with this thing. Now what happened is, we are also taking one more extra dimension outside, that is 2. So that means this is done with these elements. Then the remaining elements, we need to take one more row for this. This will equal to 2. Okay, so this is one row, this is another row, this will comprise of 2, and then 3 rows, 3 rows, 3 rows like this, and the 2 columns like this. Okay, so this is how we have created a 3D from 1D. Alright, so can we reshape an array into any shape? Is it possible? Yes, as long as the elements required for the reshaping are equal in both the shapes. So if we are comfortable with the elements whom we need to reshape, then it's okay. But now, for example, if we are taking 8 elements in a 1D into 4 elements in 2 rows, then 2D array, but we cannot reshape into 3 elements of 3 rows to 2D arrays. Okay, so 1D array into 4 elements in 2 rows, this is possible into 2D, but we cannot reshape it into 3 elements, 3 rows, okay, for a 2D. Let's see, because it should have 9 elements, okay, but we are here with 8 elements, so this condition is not possible. However, we just try to check out this thing with the help of a code. So the given example is, try to convert 1D array with 8 elements into 2D array with 3 elements in each dimension. Okay, so this will generate an error, and what error it will generate, let's see. First consider this code. Alright. So import numpy as np arr equal to np.array. So we are having 8 elements here. Okay, and in this array, and then we are trying to reshape it. Reshape means 3 comma 3. That means we want 3 rows, and each row must consist of 3 elements. Okay. However, we are having only 8 elements here. So one element is missing. So we can't perform the reshape here. Okay. So obviously it will generate an error. So let's save this code, run this code. So let's see. Okay. All right. Here is the error. We cannot reshape any array of size 8 into shape 3 comma 3. Okay, so if we just add one more element here, what does it give the output? So let's save this code and run this code. Okay, alright. So here we are getting the output. If we are taking 9 elements, we are getting a 2D array from 1D array with the help of a reshape. Okay, so this is how we perform the task. Alright, now the returns copy or a view exactly. We want to check that. We just consider one example that check if the returned array what we are getting here is after reshaping, is it a copy or it's a view. So let's consider one more code, and we will check its base. What does it returns? So here it is. So import numpy as np, again array. We are taking the 8 elements here, and we are printing reshape and dot base. Also we are just also been trying to return if it's a copy. It's a complete. If it's a complete copy, then it will return nothing, and if it's a view, then obviously it will return the value. Okay, so 2 comma 4. That means obviously it's quite clear that we are having 2 rows, and each row will comprises of 4 elements. So because here we are having 8 elements. So let's save this code, run this code. Okay, so here we are getting the complete array. So obviously it's a view. Alright. Now the next thing is unknown dimension. So we are also allowed to have one unknown dimension. What does it mean? Here we do not know how to specify an exact number of one of the dimension in a reshape. For example, if we are performing a reshape and we don't know what exactly dimension we need to give. So if in place of that we used to pass -1. That means we give a value -1. Okay, and then the NumPy itself calculate the number for you. Okay, what exactly the dimension would be. The NumPy will do this thing. Okay, so let's consider an example. Let's convert a 1D array with 8 elements into 3D array that is 2 cross 2 elements. So we are having 1D array with 8 elements, and we have to convert it into 3D array of 2 cross 2. That means we will see that how many rows and columns here we need to build. So let's consider a code here. Alright, so here it is. Import numpy as np arr equal to np.array. This is your 1D array. Okay, and then we want to convert it into a 3D array. And if we need to convert it into 3D, it's quite clear that the outside we used to we have 2. Okay, 2 value as one of the dimension. Okay, and inside this 2, it means we are having 2 rows. Okay, and this -1 because we don't know what exactly the dimension would be. So this dimension we don't know. So we are putting here a -1, and then we are printing the value of the array. Okay, so let's save this code, run this code. So here it is. Alright, so it has been converted into 3D array from 1D array. How it has been done? So it's quite clear that we have to take 2 rows. Okay, 2 rows, but we don't know how much elements we need to take in these 2 rows. So we have put -1 here. So NumPy itself has calculated that how many columns it need to create in order to convert this 1D into 3D. Okay, and we have already given 2 outside. So this is 1 row, this complete is 1 row. Okay, and these 2 means this row, okay, and this -1 means we have 2 columns. So instead of minus, there is one more thing. If we just do one change, instead of -1 we just do 2. Okay, so again it will give the same result. Obviously it's the same result. So after calculation we came to know that 2 can also be given here, but we are just doing some experiment, so we are just giving -1 and let the NumPy decide what to do. Okay, so here is the output. Now we cannot pass -1 to more than one dimension. That means we can't force NumPy to do its own calculations again and again. Now the next thing is flattening the arrays. So flattening the arrays means converting a multi-dimensional array into a 1D array. And that means we can use reshape and we give the value of dimension as -1 to it. Okay, so multi-dimensional array has to be converted into 1D array with the help of flattening. So let's consider an example. So here it is. Alright, import NumPy as NP. So this is array ARR equal to np.array. So it's obviously it's going to be a 2D array. And instead of printing it, what we are doing is we are just converting, we are reshaping it to 1D array. So we are giving ARR dot reshape -1. Okay, so let's do one more thing. We just print the value of ARR also, so it will be clear that it will print a 2D array ARR. Okay, and then we are just converting it into 1D array with the help of a reshape and -1 the value of the dimension, and let's go with it. Alright, so here it is. So it's a 2D array initially, and then it has been converted into 1D array. So this is how we do with the flattening. So there are many more functions which are available in NumPy in order to operate with the arrays. So we have seen these examples of shape, reshape and flattening in the previous tutorial also. So please go check out my previous tutorials, and we will come up with more exciting lectures. Thanks for watching. Kindly subscribe to my channel.